Today we're going to cover sections 1.5 and 1.6. 1.5 is to describe angle-pair relationships. 1.6 is classify polygons. Our objectives. Before we used angle postulates to measure and classify angles. Today we will now use special angle relationships to find angle measures. Also, we classified angles. Now we'll classify polygons. Complementary angles. Definition of complementary angles is they are two angles who sum to 90 degrees. 90 degrees is a right angle, so it's like the corner of a square. So complementary angles add up to 90. They don't have to be touching each other. You could have a 45-degree angle over here and a 45-degree angle over there. And you can still say they are complementary. Supplementary angles. Two angles who sum to 180. 180 is a line, right? So when you put the two angles together, they make a line. Supplementary angles. Now, when I was a student, I always got complementary and supplementary confused. Which is which? Which is 90, which is 180? So there's a silly little thing I use to help me remember supplementary angles. Is like supper table. A supper table is flat, 180 degrees. So those supplementary angles make a supper table, right? They make 180 degrees. So if you know that one, then you know complementary is the other way. It's straight. It's a right angle. All right. Adjacent angles. Adjacent angles are two angles that share a common vertex and side. That's a fancy way of saying they're next to each other. Adjacent means next to. And as I said, complementary angles and supplementary angles can be adjacent or they may be non-adjacent. You'll see in the examples, here's a pair of adjacent complementary angles. 25 and 65 adds to 90. And these two, they share a common ray and vertex, right? This line in the middle, that's where they share. They're touching adjacent complementary angles. Here's an example of non-adjacent. They're not touching, but they still add to 90. Both are complementary. Supplementary. Adjacent, they share a ray, and they make a line. These two don't touch, but they still sum to 180, so they are also supplementary. Raise your hand if you need more time to write this down. Everybody have it? Next slide. In the figure, name a pair of complementary angles, supplementary angles, and adjacent angles. Let's do complementary first. So our complementary angles. Give me a pair of complementary angles. Yes, go ahead.
BAC and RST.
Yes. These are non-adjacent complementary angles. BAC is here. RST is there. They're complementary. All right, so we could say angle BAC and angle RST. Name a pair of supplementary angles. Yes, go ahead.
Angle CAD and angle RST.
CAD and RST, yes. We've got, in this case, this angle and this angle sum to 180. So angle CAD and angle RST are supplementary. Name a pair of adjacent angles. Go ahead.
Angle BAC and CAD.
Yes, these two, they share this ray. So this angle and this angle are adjacent. Adjacent angles, we've got angle BAC and angle DAC. Any questions? Given that angle 1 is a complement of angle 2, if angle 1 is 68, what is a measure of angle 2? How do I figure this out? What do I do? Go ahead, yes.
You set both of the measures equal to 90. You would do 68 plus the unknown angle measure equal to 90.
Okay, so what he's saying is you could do it the way he's thinking about it. He's thinking about it algebraically. He said that 68 degrees plus the measure of angle 2 is equal to 90. And then he solved, right? So that would be the measure of angle 2 equals 90 minus 68, which is equal to 22. Measure of angle 2 equals 22 degrees. Now, when you show your work on this, you do not have to be so formal. You could just write 90 minus 68 equals 22 degrees, and then say that's the measure of angle 2. All right, two approaches. Yes?
How did you get the 90?
Because it's complement. Complementary angles are 90. Sum to 90. So that word clues you in on 90 degrees. All right, now we'll do supplement. Okay? No, it didn't. Okay, they haven't asked for a supplement yet. Let's see. So here they did the work. Here's the supplement. Given angle 3 is a supplement of angle 4, the measure of angle 4 is 56. How are we going to find angle 3? Go ahead.
180 minus 56.
Right, 180. We're going to do 180 minus 56 is equal to 124. And that's equal to the measure of angle 3. When viewed from the side, the frame of a ball return net forms a pair of supplementary angles with the ground. Find the measure of angle BCE and ECD. Let's highlight these angles so you can see them a little better. So they're talking about, we've got this angle and that angle, right? How would I, we know that they're supplementary, they form a line being the ground. How would I find the measure of those two angles without being given one of them? How can I figure out what their measure is? Yes?
Set 4x plus, was that 8?
Yes, 8.
And equal to x plus 2, and that will find the measure of what x is.
Okay, are these two angles, does it say they're equal? Does it say they're congruent? You're solving a different problem. What do we need to do here? They're not equal, so you don't set them equal to each other. What will we do? Yes?
Added up, they equal 180, so 4x plus 8 squared plus x plus 2
That's not a square, that's a degree symbol. It's a little circle. But you are correct. You add them together. So it's we would take 4x plus 8 plus 2x plus 2. Their total is equal to, supplementary is 180, 180. It's an algebraic problem we have to solve. So we would combine like terms. That's 5x plus 10 equals 180. So 5x equals 170. Solve for x. 5 goes into 17 3 times, the remainder of 20. 5 goes into 24 times 34. 34 degrees is x. Am I done?
No.
What do I need to do?
You gotta plug it in.
Yeah, we got to figure out the angles. This is just x. We've got to figure out what those angles are. So I go back to the 4x plus 8. But I'm instead of writing x, I got ahead of myself there. Instead of writing x, we'll put in 34. So 4 times 34 plus 8. So that's going to be 120, 136 plus 8, 144. Is that measure? And then my other measure is going to be x plus 2. So x is 34 plus 2. So that's 36 degrees. Those are my two measures. How can I check to make sure I've done it right? Go ahead. Yeah, we add 144 and 36. What should it sum to?
180.
180, it does. So those are the correct answers. 144 and 36. Questions? No questions. Okay. Find angle measures. Okay, this is just what we just did. Describe angle pair relationships. All right. They've got a picture of a linear pair of angles and a nonlinear pair of angles. Looking at this picture in your own words, how would you define a linear pair of angles? Yes.
It's adjacent.
They're adjacent. What else? What else can we say? What's the difference between adjacent angles and any pair of adjacent angles and a linear pair of angles that are adjacent? I mean, adjacent angles that form a linear pair. What's their difference? What distinguishes a linear pair from just adjacent? Yes.
One of the there's like a line.
Yes.
I don't know how to word it, but
Okay. They form a line, right?
yeah.
Okay. Adjacent angles that form a line. Good. I like that definition. Let me give you a little bit more formal definition. Let's call it a pair. I didn't use the textbook definition. I would say a pair. Here we go. A pair of angles who share a ray or a side, let's say a side, who share a side. That's the adjacent part of the definition. They share a side and whose non-adjacent sides form a line. Linear means line. Linear pair of angles that make a line. They share a ray. This is the ray they share. And then their non-adjacent rays form the line. All right. Any questions there? Okay. Vertical pair. Vertical angles. They call it a vertical pair here, but typically we'll just call them vertical angles. So you have to be careful with vertical angles. You can see in this picture, 5 and 8 are vertical angles, 7 and 6 are a pair of vertical angles. 9 and 10 are not. What makes the difference? What would we have to say? Yes?
They're exactly the same.
Okay, that's true. That's a characteristic of vertical angles. They're the same measure. Okay, but how, if we were defining them from what's in this picture, without talking about them being the same, well, how would you say it? What could you say about them? Yeah.
They meet at a vertex.
Okay. All right. They share a vertex. What else?
They form two lines.
They form lines. Yep. That's a key part of it. All right. What else? You're overlooking the obvious thing about them. Because if we just said they shared a vertex and they form a line, we could say 5 and 6 are vertical, which they are not. What else?
They intersect.
They're formed by intersecting lines, yeah, which is important to say.
On opposite sides.
Yeah, they're across from each other. They're opposite of each other. Okay? That's the main thing about them. They're opposite of each other, but they also are formed by lines. Not just rays, because 9 and 10 are opposite each other, but they're not a vertical pair because they're not formed by intersecting lines. They're just formed by rays going from that same vertex, right? So, let's define a vertical pair as angles formed by lines that share a vertex and are non-adjacent. Having trouble getting my pen to write here. Non-adjacent. All right? Angles, they're formed by lines. So we've got our straight lines. They're formed by lines that share a vertex. They share this vertex, but they're not next to each other. They're across from each other. All right? That's a definition of a vertical pair. Let's see how the textbook defined it. They use opposite rays. Two angles whose sides form a pairs of opposite rays. I don't like the definition with opposite rays. If that makes more sense to you, write that down. Two angles whose sides form two pairs of opposite rays. Any questions on that? Identify all the linear pairs and all of the vertical angles in the figure at the right. All right, so let's do linear pair first. What are the linear pairs in this picture? Yes?
Do you want just one?
Give me one.
1 and 3.
All right. 1 and 3 are part of making a line, but to make this line, 2 is also a part of that, right? So it's not a pair. It's 3 angles that make the line. So we couldn't say 1 and 3 are a linear pair. Yes?
Maybe 1 and 2.
1 and 2 don't make a line. They're adjacent. They share a ray, but they don't make a line. Anybody else? All right. So, 2 angles who share a common vertex and ray and non-common sides form a line. 4 and 5. They share this vertex and this ray. Non-common sides form a line. 4 and 5 is one linear pair. There's another one in this picture. What do you think it is? Right here in the front. What's what?
2 and 5.
2 and 5? No, because 3 is a part of that, making that line. Right? You have to think about, when you say 180, you got to go this way, not just straight across. Yeah, the rays, this ray and this ray form a line, but 3 is a part of that angle. Yes, in the purple.
1 and 4.
Yes, angle 1 and angle 4 are also a linear pair. Vertical angles. Give me a pair of vertical angles in the picture. In the back, go ahead.
Angle 1 and angle 5.
That's the only one. Angle 1 and angle 5. Only vertical angles in the picture. 3 and 4 are across from each other, but they're not formed by the same lines. 2 and 4, same thing. They're not formed by lines. 1 and 5 are the only 2 that are formed by the same lines. So 1 and 5 is our only vertical pair in that picture. All right, here's an algebra problem. 2 angles form a linear pair. The measure of one angle is 5 times the measure of the other. Find the measure of each angle. All right, so it's algebra. So one of the angles is going to be x. We call one angle x. How can I represent the other angle in terms of x? If it's 5 times the measure of the other? Yes?
5x.
Right, so we have x and 5x, so x plus 5x. Okay, they form a linear pair. What are they going to equal? 180. Right, they're supplementary. They sum to 180. So that's going to be 6x equals 180. Mental math, what is x going to be? 30. Right, x is 30 degrees. We've got to find the other angle. It's going to be 5 times 30. Another mental math problem. What's 5 times 30? 150. All right. Those are my 2 angles, 30 and 150. One six. Classify polygons. A polygon, poly means many, gon means side. A many-sided or polygon is a closed figure in a plane. Closed means there's no gaps. This is an example of something that's not closed, would be something like that. That is not a closed figure. There's a gap. All the line segments that make the shape do not connect. So that's what closed means. It's a closed figure by connecting at least 3 line segments. So it's got the polygon with the fewest sides is going to be a what? Triangle. Endpoint to endpoint with each segment intersecting exactly 2 others. So by intersecting exactly 2 others, that means, let's do another counterexample. If I had this, that is not a polygon because this line segment. It intersects it intersects this line. It intersects this line, it intersects this line, and it intersects that line. It intersects 3 lines. That's not a polygon. That's a polygon. That's a polygon, but together that's not a polygon because the lines cross within the figure. So, each line segment is called a side. Each endpoint where the sides meet is called a vertex. Their angles where they meet forms an angle. We know that when the angles meet, the point where they meet is a vertex. So, same term, just used in a different context. A diagonal is a segment connecting two non-consecutive vertices. Non-consecutive means as you go around, they're not next to each other. This line connects these two vertices, so those are non-consecutive. We have other diagonals in this. That's not the only diagonal. There's another one, and there's the others. See? There are 5 diagonals in this shape. Diagonals connect non-consecutive vertices. 2 types of polygons: convex and concave. A convex polygon is a polygon in which no segment connecting 2 vertices is outside of the polygon. Let's look at some examples there. Those are convex polygons. If I connect any point in this shape to any of the other points, the line is either a side or it's inside the shape. Versus concave, a polygon in which at least one segment connecting 2 vertices is outside of the polygon. If we look at this example, if I connect these 2 vertices, I used the wrong pen. If I connect these vertices, this line is outside of the shape, right? So the side concave, I think of it as a side is caved in. This side is caved in, right? So that this line would be outside of it. So it's concave. On this arrow, this side here, it's caved in. It's pushed in so that if I drew a line connecting this vertex and that vertex, it would be outside the shape. All right? Concave, convex. Then this is here in a convex polygon, consecutive vertices share a common side. These 2 points share a side. Consecutive sides share a vertex. And consecutive angles share a side. Any questions on convex and concave? They did the same thing I did. You can see where they drew the lines. Tell whether the figure in a polygon. Tell whether the figure is a polygon and whether it is convex or concave. Is this a polygon?
Yes.
Okay, I hear yes. Why do you think it's a polygon? You don't think it is. Why not?
Because it's not all pieced together, like there's a line in the middle of it.
Right. This line disqualifies it. If this line wasn't here, it would be a polygon. But this line means that there are 3 lines that touch this vertex, right? And we know by definition only 2 lines can touch a vertex. At this point, there are 3 lines, right? So, no. Now, if we took just the top half, that's a polygon. The bottom half by itself is a polygon. When you stick them together, they don't make a polygon. It's 2 polygons that are adjacent. So we can't classify this as concave or convex because it's not a polygon. Is that a polygon?
Yes.
It is a polygon. Concave or convex? Convex, yeah. There's no side is caved in. I could draw all my diagonals and they'd be inside the shape. That is a convex polygon. C. Is that a polygon? This is a curved line. Is it a polygon? No, I don't think I emphasized that when we defined it. All the sides of a polygon are line segments. A curved line does not make a polygon. Okay? So that is not a polygon because one of its sides is curved. Is that a polygon? What kind?
Concave.
It's concave, yes. The sides are caved in. Questions? All right. Classifying polygons. What is a three-sided polygon called? Triangle. Four sides is a... Okay, those are both types of them, but the more general term is... Good, yes, it's a quadrilateral. Quad means four, lateral means sides, quadrilateral, four-sided shape. Five sides. Pentagon, biggest building in the world. Six-sided. Hexagon, right. Six is hex. Anybody know seven? Yes? Yeah, good. Heptagon. Heptagon is a seven-sided shape. 8 sides, octagon. 9 sides, nonagon, good. 10 sides. 10 sides is a decagon, and 12 sides, anybody know that one? Dodecagon, good. Now, anything above 12, you just say the number of sides and say gon. So a 13-sided shape would be a 13gon. The end is a variable. A 25-sided object, polygon, would be a 25-gon. All right? Commit these to memory because this will be on the test, some type of multiple choice or true-false type question. They'll ask you one of these, okay? What is a seven-sided shape called? You're going to know it, heptagon. All sides are congruent in an equilateral. Equal means equal, lateral means side. Equilateral, equal-sided polygon is an equilateral polygon. All angles being congruent is equiangular. And then a regular polygon is a convex polygon that is both equilateral and equiangular. It's convex, and it's equilateral and equiangular. Regular is a term we will use a lot in here. So make sure you know what a regular, and here's a picture of a regular polygon. Everybody have this? All right, so a regular polygon, tell whether the polygon is equilateral, equiangular, or regular. All right, well this one, we'll do this one together. Equilateral. All the sides are marked with a tick mark. That means all the sides are the same length. Equiangular. They have one arc in each angle. That means all the angles are the same. It's not concave, it's convex. So this is regular. This is a regular hexagon. If all the angles and all the sides are marked the same, it's regular. Is this equilateral? No, it's got some equal sides. The opposite sides are equal, but not all four. They're the same. This is one mark. This is two tick marks. That means they are not equilateral. Equiangular. Same thing. The opposite angles are congruent, but the adjacent ones are not. So it's not equiangular. So if it's neither of those, then obviously it's not regular. So this is none of the above. It is a quadrilateral if we classify it. It's four-sided, but it's not any of the other special characteristics. C. Is this polygon equilateral? Yes. All the sides have one tick mark. It's got 12 sides. They all have one tick mark. Is it equiangular?
Yes.
All right. They tricked you. These boxes mean they're congruent. They mean they're 90 degrees. But these are outside of the shape, right? So the angle we have to compare the corner to, this angle compares to this angle, which would be how many degrees? No. 270, right? It's 360 minus this angle. That's 270. So we're comparing 90 and nope, they aren't the same. They're not equiangular. So it's not regular. Okay, algebra problem. This is a regular hexagon. So what do we know about its sides? They're the same. So if I want to find the length of one side, what do I have to do with this information? With these two algebraic expressions, what am I going to do? Each one represents a length of a side. Go ahead. Yes, you.
Set them equal to each other.
Yeah, we're going to set them equal to each other. So we're going to take 3x plus 6 is equal to 4x minus 2. So that's going to be, we get the x's on the same side, we'd have x equals 13, right? Oh, that's a 2. So it'd be x equals 7. X equals 7. Is that the answer? What do I need to do? We got to plug back in. So it's going to be 3 times 7 plus 6 equals 21 plus 6 is 27. Something's not right. I made a mistake somewhere. Because, what's that?
It should be 8 for x.
Oh, that's a 2. Yeah, okay. Yeah, that should be 8. X equals 8 because we moved negative 2 over. We add 2 to both sides. 6 plus 2 is 8, so it should have been 8. So 3 times 8 is 24 plus 6. That's going to be 30. Should be 30. And 4 times 8 minus 2 is 32. Minus 2 is 30. All right. So that's our check. We plug in into both. If they're both the same, we know we've done it right. It's 30. All right, that's it. That's the notes for today.